Good morning, everyone. My name is Amanpreet Singh Gandhi, and today I am excited to share with you an innovative project that aims to revolutionize disaster response, the Integrated Disaster Management System (IDMS). This system leverages advanced technology to enhance predictive accuracy, streamline coordination, and ultimately save lives in the face of natural and astronomical disasters. Join me as we explore how IDMS can make a profound impact on disaster management worldwide. The Integrated Disaster Management System, or IDMS, is an innovative project designed to predict, monitor, and respond to both natural and astronomical disasters in real time. Our system leverages advanced sensors to gather critical data, uses machine learning algorithms to analyze and predict disaster events, and employs automated response mechanisms to coordinate timely and effective actions. By integrating these technologies, we aim to provide a comprehensive solution to disaster management, ensuring swift and accurate responses to mitigate the impacts of these catastrophic events. Effective disaster response is crucial for saving lives. When we can predict and react swiftly to disasters, we can significantly reduce the number of casualties. By minimizing property and infrastructure damage, we help preserve the built environment, making recovery quicker and less costly. Reducing the economic impact of disasters helps maintain stability, ensuring that recovery efforts don't overwhelm local and national economies. Enhancing community resilience means that affected areas can bounce back more quickly, maintaining the social and cultural fabric of the community. Finally, addressing both local and global disaster challenges ensures that our system has a wide area reaching impact, improving preparedness and response capabilities around the world. Now, let us have a look at the different objectives of this project. Predict. Our primary goal is to develop a system capable of accurately predicting natural and astronomical disasters. By using advanced sensors and machine learning algorithms, we can analyze patterns and forecast events such as earthquakes, tsunamis, hurricanes, and meteor strikes. This predictive capability allows us to prepare and warn communities in advance, minimizing the impact. Real time monitoring is crucial for effective disaster management. We aim to implement a network of ground based and satellite sensors that is continuously collecting data. This data is integrated and analyzed to provide up to date information on potential and ongoing disasters. Real time monitoring enables us to track the progress of events and respond dynamically. Respond. Automated response mechanisms are essential for coordinating and executing disaster management strategies. Our system will integrate with local emergency services, automate evaluation alerts, and can manage resources such as medical supplies and shelters. By automating these responses, we can ensure a swift and organized reaction to disasters, reducing chaos and improving efficiency. Now, let us have a look at the different components of the integrated disaster management system. First, we have our early warning system. Our early warning system is the foundation of the IDMS. It includes deploying a network of advanced sensors that collect real time data from various sources, including satellites and ground based monitoring stations. Machine learning algorithms analyze this data to predict and warn about potential disasters before they escalate. Real time monitoring and reporting. The heart of our system lies in real time monitoring and reporting. A central control center aggregates and analyzes data from sensors and other sources. This allows us to provide continuous updates and alerts to authorities and the public through a dedicated mobile application. GIS technology helps visualize disaster areas and optimize response efforts. Automated response mechanisms. Automated response mechanisms streamline disaster management processes. We collaborate closely with local emergency services to implement automated protocols for immediate action. This includes automated evacuation alerts and dynamically managed resources such as medical supplies and shelters. By automating these responses, we can ensure a swift and coordinated reaction to mitigate disaster impacts. Now, let us move towards the research and development of the integrated disaster management system. Literature review. Our research begins with a thorough review of existing early warning systems and disaster management strategies. We aim to understand their strengths and weaknesses to inform the development of the IDMS. Additionally, studying the efficiency of sensor networks and predictive algorithms helps us refine our tech approach to disaster mitigation. Technology selection. Choosing the right technology is crucial. We are selecting sensors such as seismic and weather monitoring devices, as well as satellite based systems to ensure comprehensive data collection. Communication technologies like IoT and satellite communication will facilitate real time data transmission, essential for timely disaster response. System design and prototype development. The system's design is critical to its effectiveness. We are developing a detailed architecture that integrates all components of IDMS seamlessly. Prototyping sensor networks and control center setups allows us to refine the system's functionality and optimize performance. Testing and validation. Testing is a crucial phase in our development process. Simulations will assess the system's predictive capabilities, ensuring our algorithms accurately forecast disaster events. Field tests will validate real time monitoring and automated response mechanisms in practical scenarios, preparing IDMS for real world deployment. Now, let us have a look into the implementation plan of the Integrated Disaster Management System. In the first phase of the implementation plan, we have initial setup. In the initial setup phase, we will establish partnerships with local and international disaster management agencies to ensure collaboration and support. A pilot network of sensors will be deployed in selected high risk areas to start collecting data. Additionally, we will set up the central control center and integrate initial data sources to begin real time monitoring. We will also develop initial predictive models using historical data to start forecasting potential disaster events. Baseline surveys will be conducted to gather community specific information which will help tailor our response strategies. Next, we have phase 2 system deployment. During the system deployment phase, we will expand the sensor network coverage to additional regions, enhancing our monitoring capabilities. The mobile application will be launched for public use, providing real time alerts and updates. Training sessions will also be conducted for local emergency services to ensure they are well versed in operating the system and responding effectively. We will implement a public awareness campaign to educate communities on using the system and understanding the alerts. Establishing feedback mechanisms will allow us to gather the user insights and continuously improve the system. Now we come to the third phase of the implementation, full scale operation. In the full scale operation phase, we will integrate additional data sources to enrich our dataset and refine predictive algorithms for better accuracy. Regular drills and simulations will be conducted with emergency services to test and improve our response strategies. Continuous monitoring of system performance will be carried out and updates will be made as necessary to maintain optimal functionality. A 24/7 operational support team will be established to handle system maintenance and troubleshooting. We will also develop partnerships with local businesses for resource and supply chain management during disasters. Now we move to the last phase, phase 4, continuous improvement. The continuous improvement phase involves collecting and analyzing data from real world events to enhance the system's accuracy and effectiveness. We will expand international collaborations to share best practices and learn from other disaster management systems. Ongoing research and development will be prioritized to incorporate new technologies and stay ahead of emerging challenges. Regularly updating training programs for emergency responders ensures they are equipped with the latest knowledge and skills. Developing advanced analytical tools will provide deeper insights, aiding better decision making during disaster events. Now, let us have a look at the different expected outcomes of the implementation of the integrated disaster management system. Enhanced predictive accuracy. One of the primary expected outcomes of the IDMS is enhanced predictive accuracy. By leveraging advanced sensors and machine learning algorithms, we anticipate significant improvements in forecasting natural and astronomical disasters. This allows for early warning signs, giving communities the time needed to evacuate and prepare effectively. Next, we have effective real time monitoring. Continuous data collection and analysis will be a cornerstone of a system. Real time monitoring ensures that both authorities and the public receive up to date information and alerts. This constant stream of data helps in making informed decisions and responding dynamically to unfolding events. Streamlined response coordination. Our system aims to streamline disaster response coordination through automation. Efficient disaster response mechanisms will facilitate better resource management and distribution during emergencies. By automating alerts and resource allocation, we can minimize delays and improve the overall response effectiveness. Another possible outcome is increased community resilience. An important goal of IDRS is to increase community resilience. By reducing loss of life and property damage, the system helps communities recover and rebuild more quickly. Enhanced preparedness and effective response contribute to a stronger, more resilient society in the face of disasters. Now, let us look at the global impact of IDMS. The impact of IDMS extends beyond local communities. By improving disaster preparedness and response on an international scale, we can foster better cooperation and knowledge sharing among countries. This global approach enhances resilience worldwide and contributes to a more secure and prepared international community. Now, let us have a look at the possible challenges which we might face and suitable mitigation strategies to counter them. First, let us explore the different technical challenges. One of the major technical challenges is ensuring the accuracy and reliability of sensors. Sensors need to function correctly in various environmental conditions and provide precise data to predict disasters accurately. Integrating diverse data sources such as seismic data, weather reports, and satellite imagery presents another challenge. These sources must be harmonized to provide a coherent picture. Maintaining system security and privacy is critical as the system handles sensitive data that could be targeted by malicious actors. Now, let us look at the different operational challenges. Coordinating between multiple agencies can be difficult, especially during a disaster when clear and efficient communication is crucial. Ensuring community engagement and trust is essential for the system's success. If the public does not trust or understand the system, they may not respond appropriately to warnings and alerts. Scaling the system for global deployment involves addressing different regions' unique needs and ensuring the system is adaptable and scalable. Now, let us have a look at different mitigation strategies. To address these technical challenges, we will conduct regular calibration and maintenance of sensors to ensure they are operating correctly and providing accurate data. Developing robust data integration frameworks will help us combine diverse data sources effectively, ensuring the system provides accurate and comprehensive information. Implementing advanced cybersecurity measures will protect the system from potential threats and ensure the privacy and integrity of the data. Now, let's talk about our future vision. Global expansion. Our vision for the future includes expanding the IDMS to more countries, ensuring that a greater number of communities can benefit from early warnings and effective disaster response. We aim to foster international collaborations, enabling countries to share data, resources, and best practices, thereby enhancing global disaster preparedness and response. Technological advancements. We plan to integrate AI for even more precise predictions. Advanced machine learning algorithms can analyze vast amounts of data, improving the accuracy of disaster forecasts. Utilizing augmented reality (AR) can provide emergency responders with enhanced situational awareness, helping them make better decisions during crises. Incorporating drones and robotics into the system can facilitate rapid response, such as delivering supplies or conducting search and rescue operations in hazardous areas. Community engagement. Developing localized training programs will ensure that community members are well prepared to respond to disasters. These programs will be tailored to the specific needs and risks of each area. We will enhance public awareness and education efforts, empowering communities with the knowledge and tools they need to take proactive measures and stay safe. Empowering communities to take proactive measures involves not only education but also supporting them with resources and support to implement local disaster preparedness plans. Sustainability and resilience. Promoting eco friendly disaster response strategies is a key part of our future vision. We aim to minimize the environmental impact of our response efforts and contribute to sustainable development. Enhancing infrastructure to withstand future disasters involves investing in resilient buildings, transportation networks, and communication systems. Our focus on long term recovery and resilience building ensures that communities are not only able to recover from disasters but also become stronger and more resilient to future risks. Now, let us have a look into the different funding and support systems for the IDMS. Funding requirements. To bring the integrated disaster management system to fruition, we require an initial investment for system development and deployment, which includes purchasing and installing sensors, setting up control centers, and developing the software. Ongoing operational and maintenance costs are necessary to keep the system running smoothly, including regular sensor calibration, data storage, and personnel training. A portion of the funding will be allocated to research and development to ensure continuous improvement of the system, integrating new technologies and enhancing predictive models. Coming to the sources of funding, we aim to secure government grants and funding programs that support disaster preparedness and response initiatives. Private sector partnerships and sponsorships from companies invested in corporate social responsibility can provide additional financial support. International aid and development organizations are also potential sources of funding, particularly for deploying the system in developing countries. Support network collaborations with academic institutions will be crucial for conducting research, developing predictive models, and analyzing data to improve system performance. Partnerships with technology companies will help us build and maintain the necessary infrastructure, such as cloud storage, community communication networks, and cybersecurity measures. Community organizations will play a vital role in local engagement and feedback, helping to tailor the system to specific community needs and ensuring effective implementation. Sustainability plan. To ensure long term financial sustainability, we will develop a revenue model, possibly including subscription services for advanced features or data access for research institutions and private companies. Exploring opportunities for public private partnerships will provide additional financial stability and resource sharing. Implementing cost effective measures and resource optimization, such as energy efficient technologies and scalable infrastructure, will help manage operational costs. In conclusion, the Integrated Disaster Management System (IDMS) offers significant benefits by providing early warnings, real time monitoring, and streamlined response coordination. These capabilities are crucial for saving lives and reducing the impact of natural and astronomical disasters. The potential of IDRS to enhance community resilience and foster global cooperation underscores its importance. We are committed to continuous improvement and adaptation, ensuring the system evolves to meet emerging challenges and incorporates the latest technological advancements. Our immediate next step is to finalize partnerships with disaster management agencies, technology companies, and academic institutions. Securing funding through government grants, private sector sponsorships, and international aid will also be a priority. We will initiate pilot projects in selected high risk areas to test and refine the system. These pilots will provide valuable insights and help us optimize the system before a broader rollout. Launching community engagement and educational programs is essential to build trust and ensure the public understands how to use the system effectively. These programs will empower communities to respond proactively to disaster warnings. Developing and deploying the mobile application will provide the public with real time alerts and information, enhancing their ability to respond quickly to disasters. We are preparing for full scale system deployment and expansion with a goal to cover more regions and eventually achieve global reach. This will involve scaling our infrastructure, training more personnel, and continuously updating our predictive models and response protocols. Thank you.